Every frame of the video you are currently watching traveled thousands of miles from a distant Google data center to reach your screen. While Wi-Fi and cellular networks feel wireless, the data itself does not simply float through the air or bounce off satellites in orbit. Using satellites for data transmission is limited by basic physics. Communication satellites are parked roughly 22,000 miles above the Earth's equator. This diagram shows the physical limitation of that idea. Sending a signal up to that orbit and back down creates a 44,000-mile round trip. This massive distance causes severe latency, a delay that makes streaming a high-definition video nearly impossible for most internet applications. To defeat that delay, humanity built a direct physical connection, stretching from the server racks of a data center straight to your device. Before data can move, it needs a precise destination. Every phone, laptop, and server is identified by a unique string of numbers called an IP address, which acts like a shipping address for digital information. This animation illustrates how we bypass memorizing those numbers. We use domain names like youtube.com, and the internet uses the domain name system, or DNS, to instantly translate those URLs into the specific server IP addresses where files are stored. Once the request reaches a server inside a data center, it locates the video file on its internal solid-state drives. This diagram shows the data preparation process. Rather than pushing a single heavy file, the server chops the data into thousands of tiny chunks called packets. Each packet is stamped with your device's IP address and a sequence number. This technique allows massive files to move through the network as a swarm of lightweight, independent couriers, rather than a monolithic roadblock. To cross the globe, these data packets are converted into microscopic pulses of light. They travel through optical fiber cables. This is the true backbone of the internet, bundles of thin glass fibers designed to carry light signals over thousands of miles. Connecting continents requires massive maritime engineering. Specialized ships drop a plow into the sea, carving a trench into the seabed and laying the optical cable directly onto the ocean floor. On land, this cable network stretches across tough terrestrial environments, buried under hills and fields to reach our doorstep. At the end of the journey, these light pulses reach a router. The router converts the light into electrical signals, which an Ethernet cable can then transmit directly into your laptop. For mobile phones, the optical cable feeds the signal to a cell tower, which broadcasts the data through the air as electromagnetic waves. Every wireless connection is ultimately tethered to millions of miles of physical glass and steel spanning the planet. Shattered into individual packets, data doesn't follow a single path. Packets dynamically navigate the network maze, avoiding bottlenecks. They often arrive out of order, so your device instantly reads the sequence numbers, shuffling them back into the correct arrangement to play. If a packet is lost in transit, an automated failsafe kicks in. Your device instantly requests a replacement for that specific missing piece. The precise addressing, the shattering of data, the global sprint through deep-sea glass, and the final reassembly all happen in a matter of milliseconds. The internet is a meticulously orchestrated physical machine, running silently beneath our feet to deliver our digital reality.